All right, so let's make sure we understand how to interpret position versus time graphs. I have 4 examples here of an object accelerating at a constant rate. That is to say, the object's velocity is being increased by a uniform amount for every second on the clock. That is also to say that the 4 graphs you see here are every single possible permutation of an object accelerating uniformly for just a single segment of motion. That object could be moving forward while speeding up, and these, 3 other options. So now that you've seen these 4 position time graphs, I want you to be able to translate between them and their velocity time graph counterparts. So here are those, and we will flip between them pretty readily. Pause the video as needed in order for you to make your own copy of these. Okay, this is all 4 possible velocity time graphs of the exact same motion. So for example, a moment ago, I showed you moving forward while speeding up, top left graph here. This is what it looks like on a velocity time graph to move forward while speeding up. And all 3 other permutations are there as well in the same location as the position time graphs. They match up. I am in no way suggesting that you should memorize these 8 graphs, but rather learn how to interpret what you're seeing on them. For the position time graphs, recall that the velocity is always the slope of the graph. It's not so easy it's not so easy because these slopes are not constant, but I want to encourage you to use a tool that we used earlier this week in class, the zoom in tool, like a metaphorical zoom in. So look at the graph on the left side of this slide. When is that object moving the fastest? Or sorry, faster? Down here at 1 second, later on at 4 seconds. Now I used the zoom in tool, like in this case, quite literally. Here's what the graph looks like around 1 second. Here's what the graph looks like around 4 seconds. Where is the object moving the fastest? I tried to get zoomed way in to where the graphs kind of looked like a straight line. More successful in one spot than the other. Where does it look like it's going the fastest? Where does it look like the slope is the greatest? Yeah, you're totally right. It's happening at 4 seconds. So for that reason, I know that this object begins slow and ends up fast. In short, that's what you want to do on a position time graph. Zoom in, look at how the velocity is changing in order to deduce whether it's speeding up or slowing down. Now to the other thing, how do you know whether it's moving forwards or backwards? Well, again, look at these graphs. The 2 on the top row are both moving forwards. Do you notice that on the graph, they start low with a low position and they end high with a high position? And then look at the other 2 at the bottom of the page. These are objects that are moving backwards. Do you notice that they start at a high position and end at a low position? That's a negative displacement, right? So that's a negative velocity moving backwards. So moving forward starts low, ends high. Moving backward starts high, ends low on the graph. 2 details of a position time graph that you're looking for. Again, that is slope and how it changes position, the y-axis value. Okay, so hopefully you've had a chance here between these 2 pages to copy down these 8 possible graphs and begin to really try to make sense of them. When you're ready, I have a challenge for you on the next slide. And I encourage you to copy it down, pause the video, answer it fully, and then play the video. The person doing the work is the person doing the learning. So I really want you to pause the video and work this out in between the challenge and the answer. Here goes. Here's a 30-second motion that's happening on this position versus time graph. I want you to verbally describe it. So write out a few words for each of these motions. Those red dots indicate a point where something is changing about the graph. So I can't say any more than that about it, but something is changing at that point, and I wanted to draw your attention to those locations. Pause the video now and write that description and come back in a few seconds to reveal the answers. And here now is the solution set for this particular test yourself challenge. There are 4 segments of the journey. You'll notice as evidence, whenever I talk about moving forward or backwards, I'm looking at delta X, change in position. Now, I didn't highlight that on this graph terribly well, so let me do that now. So for that first segment of the journey, starting at 0 seconds and going till about 8 seconds, we travel from an initial position of 0 meters up to a final position of around 3 meters. That's what I mean. Delta X is positive. We start at 0, we end around 3 meters, positive delta X. In the next segment of the journey, we're still moving forward, a little bit further this time. So we've got a positive delta X. Positive delta X leads to a positive velocity. In the third segment of the journey, we travel backwards from a peak position of around 8 meters away from the start to a position of around -3 meters from the start. So from a +8 down to -3. That's a displacement of -11 meters. So we've got a negative velocity in this time frame. And then the second thing you can notice is that I also talk about speeding up or slowing down in terms of how the slope is either increasing or decreasing. 2 details to always look for on a position time graph: displacement and how the slope is changing. Best of luck interpreting future position time graphs.